good day, folks. Welcome back. Now we are gonna be focusing now on uh, question 4 now under organic chemistry, which is now question 4, which is a organic reaction. Okay. Now I'm gonna start here. Now we are told that these questions I continue here, right? Until 4.2.7. So yeah, do not leave me after 4.9.6. It says now in an experiment, a test tube containing methanol. Okay, methanol, propanoic acid, and a catalyst. Methanol, it is an alcohol. Propanoic acid is a carboxylic acid, and a catalyst is heated. Okay, before I even go anywhere, I'm now curious. Why are we adding alcohol and carboxylic acid? Because I have a reaction in which an alcohol plus a carboxylic acid in the presence of a catalyst, which is H2SO4 plus heat, it gives me an ester plus water. Okay, so I'm curious. Okay, I want to believe this is an esterification reaction. Why? Because now methanol and propanoic acid, they can only combine to form an ester in the presence of a catalyst called H2SO4, and it should be concentrated. Okay. Now let's continue. Okay, we can see the thingy. Now one might ask, why are we using a water there, water bath instead? Now remember, alcohol is highly inflammable, like, so it needs to be protected off from people. It is highly inflammable. It can cause danger. Okay. It catches fire easily. Come on, some okay. Another thing that you can use water for, it's because now alcohol, it is a, so we say alcohol is volatile, something like volatile. So what do we mean by when we say something it is volatile? It means it will evaporate faster. Okay. Uh, Another thing, just to make sure that the temperature it is evenly distributed, like each and every part of the methanol has the same amount of temperature. Okay. Yeah. In case you have a future papers, maybe in life science, we don't know. Grade 12, we no longer do experiments that include this. But yeah, even here they can ask you. 4.1.1 says write down the name or the formula of the catalyst. Now, the catalyst, I talked about the catalyst that we're gonna be using for esterification process. I'm sure. Now I'm sure this is esterification. Okay. Why? Because alcohol plus carboxylic acid in the presence of a catalyst and heat can only give me ester. So this is the name. It is sulfuric acid. Its formula it is H2SO4. Okay. Okay. Yes. In aqueous form. Okay. Or you can say concentrated, because it should be in a concentrated form. Okay, not a dilute. But okay, concentrated is not important. The type of reaction taking place, esterification. Remember the process of forming an ester, you call this esterification. Do not use the other word called what's this word? Condensation. No, do not use that word. It is correct, but you're gonna confuse yourself. Just use the process of forming an ester, esterification, just straightforward. Okay, what you want to do as as a student, it is that you want to do to make your life easier. Okay. Do not make yourself suffer. 4.1.3, give two reasons why we use water bathing there is preferred. Can you see now the reason that I was talking about, the importance of analyzing? The first one I said alcohol, or you can name it methanol. It is okay. Let me write it here. Alcohol is highly um, okay, let me not say highly. It is flammable. I don't like talking harder English. Like, what is flammable? So easy English, it catches fire easily. Okay. Remember, I'm trying to make you understand your content here. So let me, I'm here doing YouTube videos and I'm coming with all these big words and you don't even understand them. I don't want you to cram. Instead of using flammable, you can say it catches fire easily. You can also say alcohol is volatile. Remember, I don't use big words for without understanding more. What is volatile? Volatile means will evaporate or evaporates quickly. Okay, yes. The third one for even distribution. Of what? Of heat. Okay. Even remember it is equal. Okay, not the even near mathematics. Yeah, even numbers and odd numbers. No. Now, uh 4.1.4 they say write down the balanced equation for the for this reaction using structural formula. Okay, so we have to draw. Allow me to remove this. Probably you have taken down the notes. If not, you can also rewind back to the video and take them again. Now we are required to draw. Now we have what? Methanol plus propanoic acid. Okay, methanol. Remember, it is meth, one carbon. So we're gonna say H. This is meth. Actually, I like to put carbon. I mean, not carbon, oxygen. OH here, but it's fine. Let me put it here. OH. I want you to see something. Okay, I'm gonna add it to what? To what's this? Propanoic. Prop means three carbons. Remember propanoic acid. I'm gonna draw it like this. I'm gonna draw it like this so that I want you to show you something. H C double bond O. Remember, it has a Q, something like a Q. Okay. So remember, a functional group of carboxylic acid. It is double bond OH. So I want to start with this part. Okay. I want to start with that part like O C double bond O like that. I want you to show something. I already have one carbon. I can just add two of those. Now, in the presence, you can add H2SO4 and heat. Okay, those are the reaction conditions. I want you to see what exactly they form. What they form is that we take OH from the so where's my face going? The leading OH from the carboxylic acid, and we take the O from the sorry, not the O, the H from the alcohol. So I repeat, you take OH from the carboxylic acid and you take H from the alcohol so that they form water. So it means one of our products there, it is what? Can you see now? This is, we are talking about product plus water. So we can say H2O like that, or we can write just write water. And then now I want you to see something. When I remove this, I'm gonna bring it back. Ne? I'm gonna bring it back. I'm gonna bring it back. Yo. Okay, let me remove this. What we have took. After taking out those things, you combine these. You combine this by just taking this. Just take it here. This is the product you're gonna form, basically. This, it means this here. It is the product that's supposed to be a. This is your ish. Okay, let me do this. Let me just reverse this so that you saw okay, what's gonna be the product. Okay, good. So now you now know that OH, this and this are no longer there. Just draw it like this. Just draw everything out. H, C, H, O, this one, and it's gonna combine with this part, which is C. This one is no longer there. This one is no longer there, which is C, and then arrow, double bond, then the remainder of everything. This is, you are done. But please bring this back. I was trying to just illustrate. You are done. You are done. 1 mark for this, 1 mark for that, 1 mark for water, 1 mark for water there, and then 2 marks for the functional group there. This one. Why does it seem like I added a carbon here? So in the middle, there shouldn't be a carbon, okay? In the middle, there shouldn't be a carbon. No, just take. Okay, sorry. But in the middle, there shouldn't be a carbon. It should be just O, okay? Just O and the rest. Okay, like this. Then for the functional group like this one, it is a mark. For everything is correct, it is a mark. Let's move on quickly to 4.2, a compound A 6 carbon branched. It does not mean now it has 6 branches. It is a 6 carbon branched. It means it might have 6 carbons, but maybe let's say like these 4, and maybe 2 of those are branches. Like this. Can you see that it still have 6 carbons? This is what they are trying to say. Is used in a two-step to prepare, in a two-step reaction to prepare compound C. What is compound C? We now have the structure of compound C. Reaction 2, it is addition. This is addition, okay, sharp. Now, let's want to see what is A. A was an haloalkane, right? And it reacted to form compound B, and compound B, which is the addition reaction, formed this part. So if this is a reaction condition, it means some of them. Remember, addition reaction occurs when you have an alkene. When you have an alkene, addition reaction, because why? Because we are trying to fill the gaps. Remember, a alkene has gaps. It has double bond, meaning that it replaced 2 hydrogens. So it means we moved from an alkene to this. So now the question is, what type of alkene was that? Now we're going to apply Markovnikov's rule as well as Tsezev's rule, okay? So Markovnikov says richer gets richer, poorer gets poorer. It is when you add, when you want to see hydrogen goes away. But when you use Tsezev's rule, it says now you remove from the one with the lowest number of hydrogens. Okay? When you remove. So let's try to remove here. The one with the lowest number of, remember we are trying to go back. So now we are going back so that you can see what happened. We can eliminate H here. And I want to believe from, can you see here it was a haloalkane? It has it had halogens, and here there are no longer halogens. Okay, there are now only hydrogens. So I want to believe from here to here they eliminated the H, the halogens, all of them, to form alkene. Then here they added H2. Okay, in an addition reaction, they added H2 to fill up the gaps of the alkene. Okay, so now and the H2, now it is an addition reaction. Now I want to believe this is true. They added H2 here to fill up the gaps of eliminating the hydrogens. So it means reaction 1, it is elimination. Okay, now compound B, it is how jwang. Remember I said Tsezev's rule says when you eliminate the one with the lowest hydrogen, you eliminate from it. So we're going to take 1 hydrogen here, okay? And can you see that these ones have equal hydrogens now? Remember, we take 2 hydrogens, okay? So we took 1 here. So where can you take the other? Here, or what? Now remember, we are trying to form a double bond. You should take next to from the hydrogen that is next to that carbon you took from, which is here. So here, you're going to leave this with 2. Instead. So it means you're going to form something like CH3, which is our branch, and CH3. Allow me to write it at CH3 as well as CH3. Here we're going to have CH here, double bond, CH2. Like that. Can you see? So this is what we had. So it means A was a whatever. They did not tell us what kind of halogen was that. Let's say it was Cl here and Cl here. We remove this. Can you see? But now that's not the case. I think if I found B is the most important part. Okay. Now I'm in a position of answer. And remember, you use PT for hydrogenation. It's a PT. It is a reaction condition. PT. Okay. Name of the name or formula of the inorganic reactant. Inorganic reactant meaning it does not have carbon or in it. Okay, remember organic compounds are those that have CH in them. Okay, so inorganic reactant in reaction 2. In reaction 2, remember they added H2. So H2 is our inorganic reactant. The IUPAC name of compound B, I've already drawn it. Here it is. Okay, so we start counting from the functional group 1, 2, 3, 4. Even if I went here, it was going to be 4. Even if I went here, it's going to be 4. So it means now we have a branch, 2 branches, two methyl branches. Okay, 2 methyl branches on carbon number 3. So when I name this, it's going to be 3.3 dimethyl, because di means 2. Longest chain, it is bute what? Positional position of the functional group, it is 2, then functional group, it is in. This is your name. 3.3 dimethyl bute. Sorry, it is not carbon number 2, it is 1. Here, if it is between number 1 and 2, we take from the least number between 1 and 2, it is 1. So 3.3 dimethyl bute 1 in. Okay, the type of reaction represented by reaction 1. Reaction 1, it is elimination. I've explained why. Compound B now is now used in 2 steps to prepare for compound A. So now they take compound B, okay, compound B, they try to form back compound A. But now instead of going directly and giving back the halogens from here to here, they do it in a multi-step. So how can they do that multi-step? Remember here we have something like, it will be this, actually it will be this compound C, but now instead of this H here, we'll have Cl and Cl. So it will be something like it will be something like CH3, 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 C, H, Cl. I'm just replacing Cl. I'm not sure if it is Cl or what, okay? C, H, H, Cl, like that. Now, they tell us reaction 4, it is a substitution reaction. So now, we can substitute what? From reaction D to this one. Or if we try to substitute anything from B, so from B to something, it means here it should be an addition reaction. From B to this, we should add to remove the double bond, okay? We should add something to remove the double bond so that it becomes a single bond, okay? So that's something we can substitute whatever that it had with what? With the Cl, okay? So we're gonna try to, so the thing that we can add here, we can add water, okay? We can add water here. You can add water. When you add water, it becomes something like CH3. Let me use a different color. CH3, CH3. Remember, we are trying to remove this double bond here. Okay? So it means I'm going to add what here. And now, when I add water, the H, it is the OH, the H and OH. Remember, Markovnikov says what? Richer gets rich. Remember, this one already has what? Already has 2 hydrogens. This one has 1. So it means when we add, we will add here, the hydrogen here, because we want to make it more richer. So it means this one will be CH3, then this one will be CH, CH, like we used to before. But now instead I'm going to add H here, because Markovnikov says the richer should get richer. It already has 3, so make it rich. The poorer then will get what? is the remainder, like that. Okay, so now after adding water, now from there, from here to here, it is a substitution reaction. So I can substitute what? I can substitute, huh? Substitution reaction. So it means here I can use maybe something like HO. I can use, remember I want compound A that has only ClCl. Okay. So what I can do here is I want you to see something. I want you to see something. Compound A, haloalkane, elimination. Oh, here basically what they did so that the reaction can balance out, we did not have, sorry, here we did not have two CLs. Okay, we did not have two CLs because if it was that, it was gonna make our into wrong. We had a Cl and a H, so they eliminated the halogen, which I take as Cl. They eliminated the Cl as well as the hydrogen here. Okay, then they formed whatever. So it means our structure here, it is not Cl. It means our structure is something like this. Okay, H, like that. H, like that. Okay, so we only had one Cl. Okay, so yeah. Okay, I now see. Then now, from moving from this one, which is compound D, to compound A, they told us it is a substitution reaction. So now the only time I can substitute by adding maybe Br2. This becomes an addition reaction, or it becomes an addition reaction if I have what? If I have a if I have alkene here. But now that I have an alkane, not an alkane, a single bond what alcohol, I can add Br2 here and substitute what? Instead of OH and substitute OH with Br, it does not make sense. OH, when I eliminate it and leave it with Br, we do not have that part. So it means that we added HBr. Hence, I'm saying here, where do I take Br, manj? Let's use Cl, sorry. So can you now see it makes sense that if I add HCl here, it was the one that was removed here. Can you see? Okay, now it makes sense. So that I take this OH here, I remove this OH, I replace it with Cl, and then it forms me what? Something, and then plus water there. Okay, let's answer the questions. Oh, for this reaction where we add water, we use H2SO4. Okay, we used H2SO4. It is a catalyst. So there is this one that adds water, which is an addition reaction. Okay, it adds water also, but that water we add, it should be in excess. All right. Now, 4.2.4, write down the name of or the formula of the catalyst using reaction 3. It is H2SO4. Or you can use a phosphoric acid, sorry, H3PO4, between the two. The IUPAC name of compound D. Compound D, I've drawn it here. What is that? I'll start naming from here. This is 1, 2, 3. Let me just say 4 for fun's sake. Can you see now this is going to be a branch. So I still have 3.3 dimethyl. Okay? I still have what? 3 point, sorry, you did not do a hyphen. 3 point, okay. 3.3 dimethyl. Longest chain, it is but. Now, functional group, remember we are dealing with alcohol. I said if you are not dealing with anything alkane, your longest chain, it should be butane. Something, butane. Position of the functional group, it is in carbon number 2. Butane 2 What is the functional group thereof? It is alcohol all. So that is your answer. Or one might say 3.3 dimethyl butanol, 2 butanol. Okay, okay. Uh, oh, this is the naming for 4.2.5 basically. Okay, fine. The type of reaction represented by reaction 3, it is an addition reaction. We added what? Water. So that we can have whatever that we have and eliminate after that. So we say this is an addition. Then now 4.2.7, the type of haloalkane represented by compound A. Type of haloalkane. Is it primary, secondary, or tertiary? Now let's see. Can you see now? We're gonna check with the carbon that is bonded to the Cl, or is it bonded to the how many carbons? Now, when I see here, it is one carbon bond. Then done. This one is not bonded to that directly. This one is not bonded to it directly. Similarly, this is not bonded to it directly. So this is a secondary. Secondary is the most correct answer. So now for organic reactions, what you need to do it is to know your reaction conditions very well, um, know the type of reaction that occurs before each one. Just be strategic with what might come before what. Okay. So now let's meet on question 5, which is now rate of reaction. Thank you. If I did any mistake, please leave them in the comment section. We'll discuss them. Thank you.